Alright, this is going to be a training video on a fairly common mill turn part that we make here. So, first thing we do is how these threads are modelled like this. It could pose a problem when we do our boring and things. So what I like to do is just jump into manufacture, find whatever. If you sort of select a feature down in the tree here, or the timeline, I guess it's called, you can find these three little arrows above the feature, what you've selected it corresponds to. So let's just go in and edit this feature and just unselect modeled, so then we get sort of a visual representation of the thread, but not actually a feature. Alright, we can jump back into manufacture now. So the first thing we want to do is create a new setup. So in our setup we can define our work coordinate system, our stock, where the material sits in the stock, if we've got different G54, G55 offsets, things like that. So typically in Fusion we start from the first tab and work our way through, go to the second tab, work our way through, etc. So first thing we do is under operation type we need to go to turning or mill turn, because we're in a lathe and we've got a mill turn lathe. Spindle, if you're working on a dual spindle lathe you have the option of a secondary spindle, but for this job here we're going to use one of our single spindle lathes. So primary spindle, the next thing it wants to know is a rotary axis. So what sort of axis is the part revolving around? It's already selected this face. I'll just unselect it so you can see what happens if you sort of run into any problems. So now there's no rotary axis defined. So we can either select sort of the outer diameter. You can select an edge. Anything sort of concentric with the part is fine. So for instance we can select there, that's no worries. We can select the edge, all good. X-axis we want in line sort of with this geometry. We don't want our X running through here. So to do that we can actually select, well I should sort of show you how to manipulate the work coordinate system. If you select the tip of an arrow, it'll flip the direction of the X. If you select the middle or the base of the arrow, you can then redefine where you want that orientated. So I've selected the base. Then if I select this line here, you'll notice X-axis is now corresponding with this edge, so it runs along that edge, which is exactly what we want. Except our Z is facing the wrong way. We want Z positive to be out this way. So all we need to do is select the end of it and it flips it, and it's smart enough to know that you want it at the front because our origin is set to stock front. Now, having our origin set to the stock front is fine in CAM terms, but for the operators it's a lot easier if they have the origin set to the model front. So all the tool paths are based, Z0 is the front of the part rather than being some arbitrary value of the stock that's sticking out. So this hole, when it's programmed, it'll be actually from the machine drawing, the part drawing, everything will correspond correctly, being at the model front, if that sort of makes sense. So if this feature here was say 10 mil from here to here, when you go to do this toolpath it'll say 10 mil rather than being 12 or 13, depending how much stock you've got left. Hopefully that sort of makes some sense. Alright, we're looking pretty good here. We'll keep going through. One thing, 99% of the times when you have a mill turn part like this, you'll need to turn spun profile on. So I'll just hover over spun profile. So what it essentially does is it gets the profile of the part and revolves it 360 degrees, and then the profile that creates is what you sort of turn against So you can have a bit of read of that. It probably does a better job of explaining it than I do. So we'll just select that. Okay, so everything else is pretty right. Everything else, yeah, all good. So the chuck reference, if you have a chuck and you're sort of holding on through here, you can define your chuck. So Fusion will show you if you're going to crash or something, if you're going to hit your jaws. But for us, we'll just drag that back off the part a bit. All good, not a problem. Okay, so we're all pretty good there. We'll jump over to our next tab, which is the stock tab. So this is where we can define the material. So mainly 99% of the times for us, we'll be using a fixed size cylinder, which is a fixed size billet, or if we're bar feeding, we know the diameter of the material. Or you can do relative size box, so then you can add stock relative to each side of the box. You can go a relative size cylinder, so if the part you just want 1 millimeter all around, no worries, you can do that as well. You can go fixed size tube, and then you can also define the inner diameter, so we can say 20, and it will actually give you a hollow tube if you want to do that. For us today, we're going to go fixed size cylinder. So 70 mil diameter looks good, 150 length, not too bad. So one thing we want to do is sort of define where the part sits in the stock. So if usually I'll go offset from the front and go 1 millimeter. So then if we click the back, we can see we've got 1 millimeter of stock, so we can face it, turn it, whatever we need to do, and we're not going to have any raw parts sticking out. Looks good. Work coordinate system, we very, very rarely change on a mill turn part. It's more for mills when you're doing more than one part at once, but we can go into that into the future. Alright, let's click OK. So now, if we click the setup, we've got a few setups happen, so we'll click setup. So now our work coordinate system's defined, our x-axis is pointing in the right direction, our stock is defined and the part is sitting in the stock in the correct location. So the first thing I guess we'll do is start roughing the part out. We'll start turning the part out. So because the part sort of doesn't have a flat face, we don't necessarily need to face the part. We can just start turning this profile. So we've got a few shortcuts up the top here, but for today I'll just drop them down so you can see what we're actually doing. So the first thing we want to do is turning profile roughing. So you can see in the little display next to it what it's actually going to do. Fusion's very good. If you hover over the tool paths, it sort of gives you a good idea and a bit of writing there of what the tool path is actually going to do. We can do sub spindle transfers and all with Fusion. So let's get into it. We'll go turning profile roughing. This brings up this little dialog. The first thing, so again, we're going to start from the first tab and work our way through. So it wants to know what tool we're going to use. So we're going to select. Today we are going to not use our cloud libraries. We've got a heap of tools in here, but we're going to go and create each tool separately, just for another training aid. So the first thing we want to do is click plus to bring up the tool dialog, new tool dialog. And we want to go a general turning tool. You can fill out all this if you like, but for today and for everything you sort of do, it won't be necessary. Mainly you'll be selecting from tool libraries anyway that are pre-created. So for today we'll jump straight into insert. Typically we'll use a WNMG, and for roughing we'll use a 0.8 corner radius. Everything else we can sort of leave all good. The holder, that looks fine as well. We don't need to change anything here. You can, if you want to, you can change things, but for this case we're pretty right. Setup, if you want the sort of the tool orientated any way on the turret, you can do that, but for today that's fine, all standard. We're not doing anything too special. We can define our speeds and feeds. 0.2 for steel looks good, and this is where we define our tool number. So this is the tool number and this is the tool compensation offset, the tool offset number. So as long as you've got them both the same, you should not run into any issues. The only times we would have a different number in our compensation offset is if we're using a twin spindle lathe with different tool offsets, which we will get into the future at some stage. Fusion also supports multiple turret machines, so if you've got another turret 1 or 2, you can chuck it in there and it will work for you. Alright, so let's accept that and select our tool. So now you sort of see our tools there. It wants to know what geometry and things like that to work. So what I'm sort of a fan, if you just select OK right off the bat, you will actually get a toolpath that isn't too bad. So I'm a big fan of rather than coming in and sort of playing with everything and defining everything straight up, and then you don't really know what happens, or if you get an error or something, it's very hard to sort of to go back and work out what's actually wrong. So for me, I don't normally create a toolpath and then start tweaking it in from there. So this toolpath actually does look pretty good straight off the bat. So one thing we'll do is just go into our geometry. That's fine. So the geometry tab with turning this is where you define where the toolpath is looking relative to the front and back of the model. So at the moment, our toolpath is going to look from the model front. So our front is set to model front with no offsets, and it's going to look from the back with no offsets. So we can click OK on that, so you can see it's going from the front of the part to the back of the part. If we don't want that, we can manipulate our handles and drag them, or we can go any of these. We can go model back, we can go the chuck front, or we can go selection. We can go selection and select a point, and then we have an offset of 18, so we can go 0, and then it will be exactly where we selected. So if we select another point, we can select this point, not a problem. But for today, we will go model front. All good. The next tab over is the radii tab. So this defines the inner and outer points of where the toolpath is looking. So for instance, if we want to look from the inside, so we're going to look from the inner radius, the stock ID. So the stock inside diameter is 0. If we don't want to machine right down to the bottom, we can go diameter and set an offset of say 10 millimeters, and then you see the inner diameter actually change. So we're going to machine from the inner diameter right out to the outer diameter. So let's click OK on that and see what happens. So you can see it's left 10 mil diameter on the part that we're not roughing. So that's sort of an easy way that you can manipulate the inside and outside diameter. So if we chuck 50 in there, it's only going to look from the inner diameter, so the inner to the outer, so 25 millimeters out to 35 millimeters. No dramas. If we can go to the second tab, we can grab our back reference and bring it forwards, so it'll only look from the back point what we selected, the inner radius what we selected, so you can sort of really get in and define where your turning toolpaths sit. Okay, so let's just change this back. So we want it's still referenced from the model back because that's what was selected. So by dragging this, you can see it's actually just changing the offset. Another way you can do it is go selection and actually just select the point that you want to offset and just get rid of the offset. So our mode is selection, and what we have selected is this edge. All good. So we want to change all this back because it was pretty right. So stock back with no offset, model front with no offset. Next tab over, the inner radius, we can just go model ID or stock ID, and then no offset in that one. And that takes us back to 0. Okay, passes. This is where we set our maximum depth of cart. If we want to go vertical passes, back carting, horizontal passes, the direction, if we want to allow grooving, if we want to use a can cycle, passes, we can do maximum depth of cut, so we can go about 2 millimeters pretty safely on this. Even depth of cut means it just forces the equal same depth. Usually you don't ever need to play with that. Make sharp corners. You can see, you can read the dialogues that pop up, and it gives you a better example of what I can probably explain. But basically, make sharp corners. The toolpath will go from point to point and not roll around the corners. If you turn this off, it's actually better on the machine because it will roll around the corners and still stick to the part geometry. It won't actually gouge the part or anything like that. So this is where we can set our stock to leave on the roughing toolpath. So x-axis we usually leave about 0.5 millimeters, and on Z, so X is this way, and then Z is sort of the front. So we leave 0.1 on the front and 0.5 mil on the OD. Very good. Linking, we're pretty good with all this. Usually you don't need to change this, so we won't get too much into the linking, especially on lathes. We'll be pretty right. So let's click OK. So you can see everything looks pretty right. We've got bigger step downs. So let's just do a simulation of that. So if we jump up in here into simulate and then click play, you will get a simulation of the toolpath. Looks pretty good. So we're roughing down, 2 millimeters step down, right to the center of the part. And then we're doing a little groove at the back actually. So typically we do not want to groove with this tool. So we'll click close. We'll edit our toolpath. And then in the second to last tab, the passes tab, you have this grooving option here. So if we click don't allow grooving and then OK, you'll see that we actually get a straight toolpath off the back. Looks good. Looks good. Okay. So next we want to finish turn this part. So we'll come in and we'll go turning profile finishing. We'll select our tool, same thing again. We'll go into our setup here rather than the cloud libraries. We'll create our tools under the document that's open so far. So we'll click the plus. We want to do a general turning tool. We want a WNMG again. WNMG. And our corner radius will go 0.4 for the finishing tool. Cutting data will go 220 and 0.15, not too bad, and we'll create that under tool number 2. So a good habit to get in is every different tool, define it as a different tool number, because when we go to post this out, if everything's labeled or everything's numbered the same tool, you won't get your retracts and things like that. It'll actually it won't change tools, and if it does, you won't get the tool, you won't get the retraction, and it could index the turret right here when the tool hasn't relieved itself from the part, if that sort of makes sense. So we'll get into that later, but for now you should be alright, because we're going to create our tool libraries for you, so they should all have unique numbers. Alright, we'll carry on. Okay, so again, we haven't changed anything. We're just going to click OK and see what happens, see what sort of toolpath we get. So our toolpath looks pretty decent actually. We're doing a bit of a groove in the back here, so we can fix that straight away. So we'll go don't allow grooving. Very good. Pretty good. We do have a warning here, so we'll just see what that is. Okay, so the lead out has been modified due to a gouge with the remaining stock. So if we simulate this, we can sort of jump ahead, and then this is the last of the toolpath, so we're coming up. So what it's saying is it's modified the lead out. So normally we have a lead out that leads out on a 45. So because there's stock here, Fusion's sort of smart enough to know not to plunge into the remaining stock. So because this is sort of not too bad, we can go close, and then we can edit this, and in the leads and transitions in the last tab, there's an option, allow lead to cut the stock, a lead out to cut the remaining stock. So now we'll actually get our true lead out on the part. If we don't want that, we can turn that off, and the lead angle, see how it's 45 degrees, so it's coming out on a 45-degree angle. I think we can just change that to 0, and we'll get a straight out lead out. Okay, so we're obviously, see, it still thinks we're going to cut the stock, so we'll jump back in here, and we'll just enable that, and then we will be fine. So we get the roughing toolpath goes past, and this toolpath does not cut the stock. So we'll simulate that. Looks good. Looks good. Okay, so we're getting a couple of little errors here. So we're saying the holder collides with the stock. So if you can click anywhere on this timeline, and it will take you to that section of the toolpath. So if we just jump in here, and you can actually click and left click and drag and see the toolpath. So what this is essentially saying, that it's rapiding into the part, and then cutting. If we click info on the second tab, you can actually see what move the toolpath is in. So we're rapiding here, and we're still rapiding until we actually get to the part. So this move here is a rapid move, which is not ideal. So let's click close on that, and then our finishing toolpath, we'll edit that, and then all we do is add a value to the front of the part. So we know that we've left 1 millimeter stock. So if we go 1.5, we should be no worries. So let's jump in and click our setup, and then simulate the whole lot. So we'll jump forwards a bit, we'll slow it down a bit. Still doing it. It's because of our lead-in angle. So if we go 45 again, and then change it so the lead out is not the same, so lead out same as lead in, and then we can make that one 0. So now you'll see we actually get a lead in to this toolpath, and we should be fine. So let's simulate that again. Jump ahead. See, we're not getting a warning now. So we'll just scroll back a bit, and we'll just click again, left click and drag, and we can simulate. So we can see we're actually cutting the stock now. That's fine. Because we're cutting below the X center line, we might actually make our lead in 90 degrees instead of 45. It'd be a lot nicer on the tool. So we'll go 90. Okay, so now we get a straight lead in, and then we start cutting. That's going to be a lot nicer. Alright, so our part is essentially turned. Looks good, no errors, no red marks anywhere. Nice and easy on the tool. Very good. Okay, so next thing we want to do is start roughing out sort of this section with an end mill. So we will jump into our milling tab up at the top here, and we want to do a 3D adaptive clear, because we sort of want to rough out 3D mill up this fillet, so it's less work for our ball mill to come in and do. So we'll go adaptive clearing. Again, same as turning. We start from the left tab, work our way through. So we'll go select our tool. We will create a new tool. We will use a flat end mill, and we'll go to cutter, We have 4 flutes. The diameter, typically we'll use a 12mm as our go-to roughing tools. Shaft is fine. Holder, we don't typically need to model the holder. Cutting data, we will go 120 meters a minute. Again, you won't need to do the feeds and speeds because I'll create the tool libraries for you. So we'll just go fairly conservative here. Very good, and we'll call this one tool 3. So every tool, different tool we have is unique with a unique tool number. Alright, so we can click accept on that. We can select our tool, and we'll see our tool, it's brought it out, but it's actually facing the wrong orientation. So we can fix that by going into our geometry tab and tool orientation button. So if we just select a Z axis, so you can select, if you select this edge, the tool will be facing this way, or you can select something and you can have it perpendicular to that face. So if I select this face here, you'll see that the tool is perpendicular off of this Z face, so it'll be straight off of it. If we selected that face there, the tool will be coming out this way. Alright, well, looking pretty good. And when you're doing tool orientation, all you need to worry about is the Z. You don't need to worry about X and Y at this point. All good. So let's just select OK and see what we get. Alright, not very good. Well, it's not too bad, but it's not good. So now what we do is start defining our toolpath a little bit more. So we can go into adaptive and edit that one. And a bit similar to the turning toolpath, when you're milling, the toolpath is looking from the bottom height to the top height. So it's going to machine everything from this height here, this bottom height here, to this top height. So our bottom height, we don't want to mill right down to here. So we'll change this from the model bottom and go selection, and we'll just select this face and see what happens. So now our toolpath is going to look from the top to this face here is what we selected. So again, we'll edit this, jump into our heights tab, and see that we've selected this bottom reference as the bottom height. So our top height, again, we're looking from the top height to the bottom height. So we'll change this from stock top to selection, and we'll just select this bit of geometry, this line here. So now the toolpath is going to look from the top to the bottom, and when it's finished, it's going to go back to the retract height, and then all done. So we'll click OK. So now all we should get is a toolpath from this face here to that, which is what we have. Now, to define a boundary, see how the tool is sort of going around the whole part, because if we go into our geometry tab, all that's defined is our stock contour, which is fine. And then we see how we have no boundary under machining boundary. So if we go selection under machining boundary, we can come in and start selecting boundaries. So if we select that, you can see that the toolpath will only look in that boundary. Well, actually, it will, at the moment, it'll be allowed to go outside the boundary if you sort of look at the bottom right picture in this dialog. If I can get it to pop up again. I have to do that one. Okay, no. Sorry, that one. So inside boundary is the bottom left picture. So if we have a boundary defined by the sort of the green highlight, if you select inside, well, I'll just show you. So inside boundary, and then the tool will only stay inside this boundary. If we select center on boundary, the tool will be allowed to sort of come center on the boundary. If we select outside boundary, the tool will be allowed to go outside of the boundary. So this toolpath is okay, but what it's doing is we're only looking from the front, well, from the top to the bottom. So if we simulate this, it is going to crash. I'll just run through this a bit more. All good, finished. So now we've just plunged in, snapped our cutter, and we're going to start helixing in. Not an ideal toolpath. So a way around this, if we jump into geometry, we have nothing to select to sort of allow the tool to come out here and plunge in outside of the stock. So what we can do is we can jump back into design. We can create a sketch on this face here. I'll just get rid of the one previously done. Okay, so we're creating a new sketch. We're going to draw a rectangle. If we select back so we're orientated on that view, we can draw a rectangle. Okay, this doesn't need to be too defined, but we'll throw a few dimensions on it just for keep's sake. Okay, 20. We'll go yeah, 35 sounds good. Okay, we sort of want our boundary to end at that wall, so we can go coincident with that point there. So that line is coincidental with that point. Looks good. So we'll turn our sketch on. So we have a sketch sort of defining the boundary of where we want our toolpath to go. So we can edit our toolpath, go into geometry, and under machining boundary, under selection, we can unselect the chain that we previously selected, and now we can select this as a boundary. We'll see what happens now. So the tool is smart enough to know to plunge outside of the stock because we have a boundary that extends past the model. So we'll just turn our sketches off just because we know what we've got going on there. We'll edit our toolpath, and instead of see how the tool is sort of going outside the boundary, it's because we have let it go outside the boundary here. So in actual fact, now that we can go tool inside boundary and click OK, we should get a nice neat toolpath. Very good. Okay, because we've jumped into model and jumped back into manufacturer, we're going to have to generate our toolpaths again. So you can either select them individually and generate, or you can select the setup and generate the whole lot. So this little dialogue that pops up saying one toolpath is generated. So do you want to generate it again? So we can select no, and it will only generate the ones that aren't generated. Okay, so we'll select setup and we'll simulate our toolpath. Roughing it out, looks good. Finishing it, and then our end mill comes in. And then we'll start roughing our part out. Looks good. And it's a 3D toolpath, so it knows to go up the wall. These step downs here, these are defined in here. So the maximum roughing step down. If we go we want the tool to go 5 mil step down, and then as it climbs up the walls, it does 0.5 mil step down. So we can do that. Okay, so it's gone down 5 mil, and then that's probably, I'll go a little bit less so it's a bit more obvious for you. We'll go 2 mil. So now it'll go 2 mil step downs, and remember we're looking from this point to this point, so it's got three step downs if we do it that way, which is fine. So these tools can typically go 25 mil step down, and we will go 1 mil. That's red because we have defined the tool flute length as 20 mil when we modeled the tool, so we'll just go 20 mil. Alright, that looks good. So we'll clean up this floor now. So how we do that, we'll jump into milling and we'll go 2D contour. And Fusion's smart enough to remember the previous tool what we had. So again, everything's fine here. We will orientate our tool orientation, select the face so our Z's facing the right way. Okay, so what we want to do a contour against is this here. So what 2D contour does is it'll just machine against sort of the geometry what you picked. So we'll go OK, and you'll see that it just creates a toolpath against the specific geometry what we selected. So that looks pretty good, except we don't really want to. If we simulate it, I'll show you another thing in process stock generation in a sec. So we'll simulate, looks good, roughed our part out, and then we come in up here and we clean up the floor. Okay, so if you notice, it's not ideal because we've still got all this stock left here. So what we can do, edit this toolpath, go into your passes tab, and then you have multiple finish passes. So if you turn that on, so this will allow you to do multiple finish passes and control the step over. So at the moment that'll do two finish passes with a step over of 1.2 millimeters. So we'll click OK and see what happens. Good, but not ideal again. So we'll edit this. We'll go step over of say 11.5 because we've got a 12 mil end mill, and then we can throw a few more passes on here. Okay, better, but we've got wasted motion out here now. So if we simulate that from the start and jump in, shortcut a bit here. So that sort of a lot of wasted motion in this toolpath now. Other than that, it doesn't look too bad. So we can define that if we edit our toolpath, jump in and turn stock contours on, and then only select this area. It'll sort of start trimming our toolpath to only cut the stock what we selected then. And another thing, we want to sort of see how it's coming in and turning, and it's sort of leading in on the part. If we turn our stock off, it's leading in on the part. We'll jump forwards a bit. It's not ideal. So what we can do, we can edit that. In our last tab, we have our lead-ins, so we can go the sweep angle of 0 degrees, and then we'll get just straight lead-ins. And if we want to add sort of a bit of an extension to these, we can jump into our geometry tab and add a tangential extension of say 2 millimeters, and then we'll actually extend the toolpath 2 millimeters and get a decent toolpath. Alright, so we've roughed our part, we've finished the OD, we've roughed out the milling, we've cleaned up the floor. Now we need to do a cleanup pass to clean up this fillet. So again, we can go milling, we can do a 2D contour, we can select our tool, we want to create a new tool, we want to create a ball and mill, going to cutter, and we want a 12 mil because it is a 6 mil fillet. Everything else we've been through plenty of times now. We've got a unique number for a unique tool. So we've got 1, 2, 3, and 4. Very good. Select that. So our tool's facing the wrong way. We'll jump into our geometry tab. We will go into tool orientation. We will select that face to get our tool orientated in the correct position. And then the contour we want to select is actually this one. Now, see what that's done? It's tried to select the whole chain. If you select the selection again, it gives you this little pop-up. So if you want to close contour, you can have it closed, or if you go over and select open contour, it'll actually let you select any lines. So anything that's blue, it'll let you select that. So if we click plus on that, it'll give us that selection. If we select the blue again and we deselect these lines and then click the plus, you'll get a toolpath that you like. Alright, so we'll click OK on that. So not bad, but we need to be machining to the floor. So if we simulate this, I'll show you what we get. We'll turn our stock on, simulate it. We'll just jump through to the last toolpath. So we've cleaned up the floor. Okay. We're going to come in with our ball mill, but see how it's not going deep enough? Alright, so to fix that, we click close on the simulation, we edit this toolpath. In our heights tab, we can simply select as the bottom height. We can go selection and select this face. So now the toolpath is trying to machine this contour, but machining down to this height. So if we select OK, that is exactly what we want. Except because we've selected this contour, it's not actually going off the part. So again, edit that, and we'll go into our geometry tab and just throw a tangential extension in here, so 5mm. Again, we can change our lead in, our linking tab, change that to 0, and then OK. We'll get a straight lead in. Alright, we'll simulate all that. Let's see how we're looking. Better make sure this is still recording. Yes. Okay, we're roughing our part out. We're cleaning up the floor. And then beautiful fillet there. Dropping in, doing our fillet. Very nice. Okay, we can click close on that. Now, this toolpath, and this toolpath, I'm just holding shift to select multiple toolpaths. So we can highlight these toolpaths, and because we want to get them on the other side of the part, we can right click and actually go add to new pattern. If we click that, this dialog box appears, and what we want to do is a circular pattern. And the axis we want to revolve our pattern around is, so again, you can select the outside, you can select that does not matter. Number of instances, we want 2. If we go 3, we'll get 3, 4, we can really manipulate our toolpaths here. Okay, so looks pretty good. So we're patterning all our milling over to the other side, so we'll click OK. We'll click setup, and then we'll give this a simulate from the start. Speed it up a bit. Finishing toolpath, milling, roughing, cleaning up the floor, and then jumping over to the other side, roughing it, doing a fillet on that side, and then the fillet on this side. Very good. Okay, next thing we will tackle is this bore. So we'll jump into milling, and we'll just bore it out with the end mill. So we'll go 2D bore, and it will remember our tool from last time, which is a ball mill, which is not what we want. So we'll select our tool, and we'll come in and select our flat end mill. We'll go OK. The orientation's wrong, so we'll go into tool orientation, select our Z axis. Very good. Okay, what do we want to bore? So it's asking us what's the circular face selections that we want to bore. So we want to bore this hole, and we get a toolpath. Alright, so this toolpath is only looking from sort of this lip to this lip. So to change that, we go into our heights tab, and our top height, we go selection, and then we'll select that. So now you can see the toolpath is actually starting from the top, and then we want to go the bottom. We'll go selection, bottom, and then we'll add an offset of -1 just to poke us out of the hole to make sure we actually do break through. You can add an offset of 1 in the top as well if you like, so then it's got a bit of clearance top and bottom. Okay, so that will simply ramp in, lead out, and then pull out. So one thing we can do is do a final cleanup pass in this toolpath. So if we go into passes tab, and then we click finish passes, and we'll put say 0.1 of a millimeter, you'll see it bores right down and then drops down again and does one final cleanup pass. I'll simulate that so we can have a look. So simulate, we'll turn our stock off, we'll simulate it, so we're boring in, and then we'll get to the bottom, we'll lift up, drop down, and do one cleanup pass around the whole lot. Okay, so this is saying the shaft collides with the stock. That's just because the flute length, we haven't actually defined it as 25 millimeters. Okay, that looks good. So we'll throw a chamfer on here. So to do a chamfer, I go 2D not adaptive. We'll go milling 2D contour. We want to select our tool, which we haven't got one, so we'll create one. So go the plus and we'll go chamfer mill under milling here. And under cutter, we'll go 10 mil, that's fine. Tip diameter will go 0, so it's just a solid carbide chamfer tool. Cutting data, we'll leave that alone. Post processor, we'll give it a unique number, which is 5. Accept that, select that. We'll orientate our tool because it's not in the right orientation. So again, under geometry, under tool orientation, we'll select the Z axis. And then under contour selection, it's asking us what do we want to chamfer. So we will select the top of this geometry. And then if we sort of click OK now, what we get is a toolpath that just follows that contour perfectly. So what we want to do here is just offset our tip down a bit so we actually chamfer the part. So how we do that is we close our simulation, we edit this toolpath, we go into our passes tab, and then we have chamfer tip offset. So if we go 3 into there, it'll actually offset our tip down 3 millimeters. So our tip is offset 3 millimeters from here. And that is how you do a contour on an already modeled contour. Alright, so I will show you how to do a contour that is not modeled. So we'll delete this toolpath. We'll jump into design. I will select that chamfer and delete it. We'll jump back into manufacture. We will do a milling 2D contour. We'll select our chamfer tool, which is this one. And then under geometry, again, we'll select our contour. And we will align our tool, so tool orientation, select a Z axis, and then it will actually show you selection properly. Okay, under passes, this is, so now we can sort of use the chamfer width. So if we go 1 millimeters and 3 millimeters, it'll go in 1 millimeter and then drop down 3 millimeters and do a chamfer. We will simulate that. So you can see that it is actually cutting a chamfer now, and it's offset the tip down. Hopefully that makes some sense to you. Alright, so we will create another contour up here. So we'll have this one defined with not modeling the chamfer, and this one we'll do it with the chamfer modeled. So again, under milling, we'll go 2D contour. We select our chamfer tool, which is already selected. We'll go to geometry tab. We'll select tool orientation. We want to orientate it this way, so Z's pointing up. And then our contour that we want to machine is this one. We jump into our passes tab, and because we've already have a chamfer modeled, you don't need to put a width in. All we simply do is offset the tip down. So we click OK. Beautiful. Alright. Because we jumped into manufacturer and made a change to the model, we just need to regenerate our toolpaths. We'll let them generate. Very good. We'll simulate our setup. Turn our stock on. Should be pretty close to be done with the milling for Op 1. Doing our bore, chamfer. Okay, a little trick is if you come up here and turn the model off, you will get an accurate representation of your part because the model is not actually there. Looks good to me. So we'll turn our model back on. We will close our simulation. Okay, let's tackle this bore and this tap. So what size is this bore? We can go to measure, turn off our snap points, and then select this wall. Say, okay, that's a 20 mil diameter. So what we'll do is we will bore this out. So we'll go milling, we'll go 2D bore, we'll select our tool, flat end mill, we will orientate our tool, we'll select the circular face, and we're looking good. So what it's doing is, no, we are alright, because it's looking from the top of that bore. If the toolpath started a little bit below, all you need to do is go into your heights and just add an offset, some value into your top height, because again, it's looking at the top of the hole down to the bottom of the hole. And you can change these as well. So if you don't want it to go to the bottom of the hole, you can go selection and select something else. Not that there's anything to select. You can select down here and it'll actually bore right down to the bottom. So, but for today, all we want to do is bore down to this face. So that's fine. Again, we'll throw a cleanup pass on it. So under passes, we'll go finishing passes and just add 0.1. So it actually leaves you a lot nicer finish. So we'll go OK. Now we want to drill this hole. So the diameter is why it's a little bit tricky when you model the threads. So I think it was modeled before you turned on. Yeah, it was modeled before the design history was captured. So what we can do, and I don't have the drawing on me, so let's say it's 8.7, which I think it's probably just a 1/8 BSP hole. So manufacture, we're going to milling, we'll go to drill, we will select our drill, we'll go to mill training, click the plus, and then we want to go drill. So we want the diameter as 8.7. All good. We won't worry about the phase and speeds for now. We'll go accept, select. So now we've got our drill. We'll orientate our drill. So tool orientation. We can select. So now you can select that line, this bore. We'll select the bore. Okay, so now our tool is orientated correctly in Z, and then the faces that we want to drill is not going to work. So because we can't actually select a face, well, we can select that one, I guess. So let's select that one. So now it knows that it's thinking that we only want to drill this bit, which is fine. So we'll change our heights. Hopefully this is making sense. To the top height, we'll go selection, so we want to drill from there, and then the bottom height we want to drill down to there. So now you can see that it's not correct because our drill is only drilling to here, so the tip is drilling to here. So we can offset that down, -1, -2, -3, just to get us into that cavity. That's fine. Now to do peck drilling is all done under cycle in the last tab. So drilling and wrap it out, we'll simply drill in, wrap it out. You can do dwell and wrap it out, so it'll get to the bottom, dwell and wrap it out. You can do chip breaking, so it'll partially retract as it's going in the hole, so it'll go in, retract a bit, go in, retract a bit, go in, retract a bit. Or you can do deep drilling, full retract. So let's do that. We'll do 1mm peck, so it'll go in 1mm, retract fully, do another 1mm, retract fully. In real life, not necessarily, you wouldn't do a 1 mil, you'd say 3, but for such a shallow hole, we probably wouldn't even peck anyway. Alright, so let's simulate that. Let's turn our stock off and let's simulate our drilling. Very good. Okay, to do a tap, what we do is go milling, drill, we'll select our tool, we'll select the document that we have open, we'll click plus, and then we'll go tap. tap right hand. Okay, so to do a tap with which is 1/8 BSP, I believe the pitch in millimeters is 0.907 from memory. And then our cutting data, how fast you want to tap. So we'll go about 6 meters is a minute is pretty right. And then we'll go accept. Okay, so we actually have a tap that's 10 mil diameter and 0.907 thread pitch, which is right for a 1/8 BSP. We can go into our geometry, orientate our tool that way, and then the whole faces that we want to tap, we'll go the same again. We'll do this because we can't select our faces because the geometry is modeled. And then the bottom height, so top height will be, we want to tap from here, and then the bottom height we want to tap selection to there. Usually you want to offset it up, say 1 millimeter, so we're not actually tapping right to the bottom of the hole. So if we had a 0 offset in here, it will tap right to the bottom of the hole, so we'll just chuck a 1 just to give us a little bit of clearance. Okay, and our last tab, we have tapping selected. Perfect. Now, because we have another grease nibble hole on the other side, we will grab these 3 tool paths, add to new pattern. We'll go circular pattern, select the axis we want to circulate the tool path around, and we want 2 instances. Very good. We'll simulate the whole lot. Turn our stock on. Roughing the part out. Finishing the part. Milling the part. Finishing the floor. Roughing it out. Boring. Okay. Drilling. And then a tap. Very good. Now, to part off the tool, to part off the part, we go close and we want to go turning part. Okay, select the tool we want to use, select our document, click the plus, and for a part off we'll just go general grooving tool. Go to our insert shape will be square. See up there, so now we have a square insert. The width of the insert, so the width of the tool is 2.7 is fine. The groove width is 3 millimeters. The corner radius is 0, and then the head length can be 5. Looks good. Looks good. Holder, that's fine. Setup fine. Cutting data we'll get that off the packet afterwards, but something like for this we'll go a fixed speed of say 600 and 0.08 will be pretty conservative. Post processor, we'll give it a unique tool number, click accept, click select, and then it's smart enough to already know what we want to part off because it looks at the model at the back. Again, you can manipulate this, you can grab the handle, you can part off anywhere, but we want model back with a 0 offset. You can do reduced infeed and speed on your part off if you want, so once it gets to a certain X diameter, it'll reduce the speed and feed. Very handy. Linking, we don't really need to do anything. Alright, so let's simulate a full setup. So when we do mill turn, we do the turning and the milling all in the one setup. Looking good. Alright, stay tuned for some boring. We'll do another setup and then we'll bore this out, and I will teach you how to do boring.